Hi, and welcome to the best place on earth, a hockey rink. Yes, we are in the depths of Canada, and we're not going to be focusing on hockey today. We're going to be focusing on some review session material. So, put your pads on, get on the ice, and let's get at it. Okay, so what are we going to focus on? And I think the focus today is going to be on how to solve certain types of equations that might seem a little more complicated than your typical multi-step equations. So let's start off right away, and let's say we had 12 is equal to 3 times, in brackets, 2 plus d. D is my favorite variable, of course, plus 6d. Now this one causes some problems just because this 6d is hanging out here. So a lot of kids forget about the 6d. So let's go and expand our brackets. So we're going to distribute right here. So I'm going to do that, and we get 12 equals 6 plus 3d plus 6d. Now, we want to combine like terms, and I'll show you something a little a visual that sometimes helps kids, is you want to combine terms on the same side. So here's my side, this side, the right side. What could I go and combine? I can combine positive 3d and positive 6d. Notice how I always circle the sign to the left. That makes things just a little bit clearer to make sure you don't make any kind of like small little tiny mistakes. So positive 3 plus 6 is just positive 9d. And I still have this 12 over here. Okay, so we've done that part. Now let's go and isolate our d. So I'm going to subtract 6 from both sides. And when I do that, I get 6 is equal to 9d. And then to get my d all by itself, I'm going to divide both sides by 9. And being a good math student, you would say that, hey, I have to go and simplify this 6 over 9. Divide both things by 3, and I'll get 2/3. Woo! There you go. You can draw your happy faces. You know what I'm going to give you? I'm going to give you today, I'm going to give you my happy bear. There's my happy bear. There's my little bear. All right, on to the next question. Here we go. Let's say we had something that had, I don't know, negative 8 is equal to 3/4 times 12 plus 5d. These are ugly numbers. You ought to call these ugly numbers. There's a lot of different things that you could do with this one. So you might want to know where you want to start. Some students might want to go and expand the brackets, which you could definitely do. Some kids might want to divide both sides by 3/4, which you could do. There's lots of different ways to go about it. The important thing is to make sure that you're following algebra rules. I'm going to show you the typical way that I see most students solve this one and tackle it, is most students will go and expand the brackets. So let's just go and do that. So negative 8 is equal to, what's 3/4 times 12? 3/4 times 12. That gives us 36/4, which is just going to be 9. And you can use a calculator for that if you wanted to. And then we're going to get a 15d/4. Oof. Now these are ugly numbers, but fear not. It's not that bad. I'm going to go and I'm going to subtract 9 from both sides. And that's going to leave me with a negative 17 is equal to 15d/4. Okay. Now what I like to do, here's a little tip for you. When you have a number over here that has no denominator, just make your life easier and just put it over 1. Okay, so that's going to look really nice. Now it looks nice and balanced. I like doing that. So how do I get d all by itself? Some kids would say divide both sides by 15/4, which is the exact same thing as multiplying by the reciprocal. So I'm going to multiply by 4 over 15 on both sides. So when I do that, I really like this color blue. It's a nice blue, isn't it? When you do that, that eliminates all of this stuff and it leaves us just with D, the best variable ever. And then you just have to go and do this. And honestly, I'm using my calculator for that one. I haven't had enough coffee yet this morning, so let's see, we got 4 over 15 times your negative 17, so your answer is going to be negative, and you get a gorgeous answer. Like, this is a great number, with D being negative 68 over 15. There you go. So let's take a look at another question involving a fraction. Let's start off with a 4 bracket x plus 2. And let's put it all over 5. And let's have it equal to 2 bracket x plus 1 all over 7. Now what you might want to do is just pause the video right now and go and try it on your own and see what happens. And then come back. Okay, so now you can, with the magic of technology, you've resumed it. Let's see how I would go and tackle this. So let's talk about what students might do. Students might go and expand the brackets. Might be their first thought. I would not do that. Some kids might want to try and get rid of denominators by multiplying both sides by the LCM of 35. That would be an interesting choice to do. What I would probably do, though, is I would go and cross multiply. So I want to show you that one right now. So when we're cross multiplying, and we can do this because a fraction is equaling another fraction, is when you go and you cross multiply, and let's go and deal with the orange circle right now. You're going to go 7 times this. Just 7 times 4, so 28. Nothing happens inside the brackets. It's still x plus 2. So a common kid mistake is to multiply the x and the 2 by 7. Doesn't happen. And what happens on the other side? So in that purpley kind of bracket, this is just 5 times the 2. So you get 10, and then the x plus 1. Again, let's make that look a little bit neater, shall we? Let's go and get rid of that stuff. There we go. And make it the x plus 1. Whoa, what just happened? Craziness. I want to get rid of this. Probably click on that x. There we go. X plus 1. Back to normal. There we go. So now we've got this kind of equation. Now I would say you probably feel, hey, that looks a little more comfortable now. Now I would definitely go and expand my brackets. And there are different ways to do these kinds of questions. So don't feel like this is the only way to do it. And that is good to kind of realize that as long as you're following math rules, it's all good. Now I'm going to go and let's choose a blue color. I want to subtract 10x from both sides. And I'm even going to do 2 steps at once. Your teacher might hate you for this, but I'm using different colors, so it's pretty obvious, hopefully. And what does that leave me? Well, 28 minus 10x, we're going to go way over here. And that's going to leave me with an 18x is equal to 10 minus 56, so I'm going to get negative 46. To get my x all by itself, I'm going to divide by 18, divide by 18. And of course, I'm going to go and simplify that whole thing. So my x is going to be equal to, I think, negative 23 over 9. It seems a little bit ugly, but things to take away. Cross multiplying is really important. And then distributing. And remember, you can do this. If you go slow, breathe, you can definitely handle this question, for sure. Let's take a look at something else. So we're going to take a look at a classic word problem. Take a look at a classic word problem. And the word problem is going to sound something like this. The sum of, so the sum of 3 consecutive, and I'm going to say even Ooh. 3 consecutive even numbers is 60. And I just want to know, what are the numbers? So let's talk about a couple of things first off. When you're talking about consecutive numbers, so maybe you are thinking 31, 32, 33, those are consecutive numbers. And if you ask yourself, if 31 was x, how algebraically would you get to 32? Well, you just go x plus 1. And then how would you get to 33? X plus 2. And so on and so on. But we're talking about even numbers. So maybe for even numbers, you're thinking something like 40, 42, 44, and so on. Well, if x is my first, how do I get to 42? X plus 2. And then x plus 4. This always is the same pattern algebraically for all of my consecutive number questions. But I'll show you a common kid mistake, so the KKM. So where's the KKM? And it's not in this question, but it's when, instead of saying even, we say odd. Consecutive odd numbers. So when you're thinking of consecutive odd numbers, we're thinking of numbers maybe 7, 9, and 11. But the word odd throws off students all the time. If our first number is 7, how do I get to 9? It's x plus 2, and then x plus 4. Does that look just like what we did down here? For sure. But where kids get confused is they said, well, it's odd numbers. Why are you adding 2 and 4? Those are even numbers. Well, it doesn't matter. It's the same algebraic process. So, without further ado, let's go and tackle this question. The sum of 3 consecutive even numbers is 60. I'm going to use lots of colors because I'm having fun with all my colors today. And the first number is x. And the word sum means to add. So I'm going to add now the next number. And algebraically, the next number is x plus 2. And I'm going to keep adding. The next one is x plus 4. That word is means equals. And then we got 60. So this isn't too bad. Let's go and combine our like terms. So we have 3x's plus 6 is 60. So I'm going to go and subtract 6 from both sides. So 3x is going to be equal to 54. And if I divide both sides really small by 3, let's see, what's my final color going to be? I'm going to go with this nice kind of turquoisey. X would equal 18. 18 would be the number. So if I wanted to know what are all the consecutive numbers, the consecutive even numbers, 18, 20, and 22. If I added all of those up, I would get to 60. So there's some review for everybody. A little bit of word problems, a little bit of solving with some multi-step equations, and hopefully you're in good shape for whatever kind of math questions are thrown your way.
Okay, it's going into overtime now. Let's take a look at some challenging material and review some of the concepts that we've touched upon in the past. All right, keep your stick on the ice and always aim for the top corner. Here we go.
Okay, so for challenge, I just want to show you one little review question, and that would be on work problems. So here's a situation that we might have. There's these two guys, you might have heard of them, Luke and Han. And maybe they're back on Tatooine, and they're harvesting a field. I'm not too sure if Tatooine had fields, but if it did, had he done it alone, it would have taken Han only 12 hours. But together, when they worked together, good teamwork, it took only 4 hours. But I want to know, if Luke was all by himself, how long would it take? Well, a little reminder that these questions use this formula, 1 over time of person number 1 plus 1 over the time of the person number 2, and then 1 over the time together. So time together. So one of those bottom things, one of these bottom parts are going to be x. So ask yourself right now, do we know how long it took Luke? Not at all. So we're going to make that 1 over x. But we know that if Han was working all by himself, he didn't have Chewie there, or C-3PO, or R2-D2, it would take him 12 hours. But together, we know together, when they work together, wow, it is cut down considerably. So now we just go and solve it. Well, that's not too bad. I would go and I would subtract 1/12 from both sides. So a quarter minus 1/12. And that is definitely a calculator situation. So remember, your calculator is your friend. And you get 1/6. So now you know that 1 over x, oops, 1 over x is equal to 1/6. So, you can just look at this and say, these are equal, so what does x have to be? It has to be 6, if you just look at it. But if you wanted to use algebra, you could cross multiply and solve. You can go and do that if you wanted to. So here you'd get x times 1, which is just 1x, and 6 times 1 is just 6. So you can just kind of see it there algebraically. So how long did it take Luke to do it all by himself? 6 hours. He's a little bit slower than Han, which, if you've seen the movies, it might make sense.
All right, hockey fans and math fans, thanks for checking in. Hopefully you guys got a good sense of what's upcoming. If you have any questions, feel free to drop me a line. Till next time.